Hello students, welcome back to the math class. In our last class, we have discussed many concepts about surface area and volume. Students, let us now discuss exercise 13.1. Question number 1. It says a plastic box 1.5 meter long, 1.25 meter wide and 65 centimeter deep is to be made. It is opened at the top. Ignoring the thickness of the plastic sheet, determine the area of the sheet required for making the box and the cost of sheet for it if a sheet measuring 1 meter square costs rupees 20. Okay. So, let us discuss the solution. We have the dimension of the box, that is length, breadth and height. So, length is given as 1.5 meter, breadth 1.25 meter and height, that is 65 centimeter, or I can say it is as 0.65 meter. Fine. So, let us first find out the area of the sheet. Okay, area of the sheet. You need to remember that the top is opened. Okay. So, the top is open. That means we are left for the area. It is actually 2LB plus 2BH plus 2LH. But as the top is open, so one of these area is not to be included. So, that means the actual area will be LB plus 2BH plus 2LH. Okay. Hope you understand this concept, because length into breadth, it is for the bottom and the top, that is why it is 2LB, but in this case as the top is open, we have to exclude one of the area of the surface. Fine. So, area now it is equal to length into breadth, that means 1.5 into 1.25 plus 2 into breadth into height, that is 2 into 1.25 into 0.65 plus 2 into LH, that is 2 into 1.5 into 0.65. Fine. So, when we calculate this, you can do the calculation by yourself. So, after calculating, it comes to 1.95, 1.5 into 1.25 gives us 1.95 plus 1.25 into 0.65 whole into 2, that gives us 1.875 plus 1.5 into 0.65 into 2, it gives us 1.625. Okay. So, when we add, we get 5.45 meter square. Okay. So, this is the area, that means your surface area of the box excluding the top, because it is open. Okay. Okay. Now, this is the solution for bit 1. Bit 2 asks for the cost of the sheet. Okay. So, cost as it is given for 1 meter square, it is rupees 20. Okay. So, for 5.45 meter square, it will be 5.45 into 20, that gives us rupees 109. So, now this is the cost of the sheet. Okay. So, we have found out that the area that is to be covered is equal to 5.45 meter square and cost of the sheet is rupees 109. Students, you please concentrate on the calculation part, because as it is decimal calculation, you need to do it properly, otherwise your answer will be wrong. So while calculating, calculate with full concentration. Okay, students, let us now discuss question number 2. What it says? The length, breadth and height of a room are 5 meter, 4 meter and 3 meter respectively. Find the cost of whitewashing the walls of the room and the ceiling at the rate of rupees 7.50 per meter square. So students, we need to whitewash, that means the walls only and the ceiling. So just remember, concentrate on the surfaces that are needed to be covered so that you can find out the actual solution. So let us discuss the solution. Okay. Students, the given dimensions of the room are length 5 meter, breadth that is equal to 4 meter and height that is 3 meter. Fine. So whitewashing of the surfaces. The walls are to be whitewashed. That means the walls, those are covering the lateral surface area. And the ceiling, it has one surface. Okay, that means in total we need to cover 5 surfaces. What should be the lateral surface area? The lateral surface area which is in this case surface area of the walls, that is 2 into L plus B. So that is equal to 2 into 3, 5 plus 4, 6 into 9, 54 meter square. So this is the area of the walls. Okay, this is the area of the walls. But we need to whitewash the ceiling as well. So we have to add the area of the ceiling with the area of the walls. So what is the area of the ceiling? Area of the ceiling. Area of the ceiling means it's covering length and breadth. So L into B, that is 5 into 4, 20 meter square. Okay. So the total surface area, is equal to 54 plus 20, that is 74 meter square. So this is the surface area of the room which is to be whitewashed. Okay. Now students, we have found out that 74 meter square of area is to be whitewashed. Now we need to find out the cost. So cost of whitewashing is, for 1 meter square, as it is given in the question, for 1 meter square it is rupees 7.50. So for 74 meter square it would be 74 into 7.50, and when you calculate we will come to the conclusion that it will give us rupees 555. So the expenditure for whitewashing the walls and the ceiling of the given room will be rupees 555. Hope you have understood this. Again I am telling, just concentrate on the calculation part, okay, so you can reach to the exact solution. Fine. Students, let us now discuss question number 3. It says the floor of a rectangular hall has a perimeter 250 meter. If the cost of painting the 4 walls at the rate of rupees 10 per meter square is rupees 15,000, find the height of the wall. Okay. So let us discuss the solution. Fine. So students, there is a rectangular hall. Fine. And the perimeter of the floor is given. That means, what is a perimeter? It is your 2 into L plus B. Okay. Now let us have length, breadth and height as L, B, H. Okay. So perimeter 2 into L plus B, 2 L plus B. Do you have your length and breadth? No, but the perimeter is given. So 2L plus B is equal to 250 meter. It is given, right? The perimeter is given. Now area of the four walls. Area of the four walls is equal to 2HL plus B. 2L plus B is equal to 250 meter. That means it is 250 H meter square, because we are not given the height, isn't it? Now cost of painting the four walls is rupees 10 per meter square. Okay, rupees 10 per meter square, and the total is equal to rupees 15,000. Fine, rupees 15,000. That means total cost rupees 15,000, cost per meter square is equal to rupees 10. Okay. So from here we can find out the area. Okay. So area is equal to 15,000 divided by 10, that is 1500 meter square, isn't it? So it is 1500 meter square. So what we have found over here, 1500 meter square and your 250 H meter square, area of the four walls and cost of painting. That means now we can equalize both of them, isn't it? We can equalize both of them. How we can do it? So it implies that 250 H meter square is equal to 1500 meter square. That means H is equal to 1500 divided by 250, that is 6 meter. That is 6 meter. So in that way we have come to the conclusion that this shows height is equal to 6 meter, which was the required data. So we have found out the height of the hall, which is nothing but 6 meter. Okay, hope you understood this. Students, let us now discuss question number 4. It says the paint in a certain container is sufficient to paint an area equal to 9.375 meters square. How many bricks of dimensions 22.5 centimeter into 10 centimeter into 7.5 centimeter can be painted out of the container? That means we need to paint some bricks. The dimension of the brick is given. Okay, the amount of paint, that is not given, but it is sufficient to paint 9.375 meter square of area. So let us discuss the solution. Okay, so the dimension of the brick is given, that is 22.5 centimeter into 10 centimeter into 7.5 centimeter. That means these are the length, breadth and height. Fine. So total surface area, why we need to find out the total surface area? But because each brick is to be painted throughout, so it has to be covered. All the areas, that is outer part of the brick, which is nothing but the total surface area. So we need to find out the total surface area of each brick, that is 2 LB plus 2 BH plus 2 LH. That is nothing but 2 into 22.5 into 10 plus 2 into 10 into 7.5 plus 2 into 22.5 into 7.5. Okay. So now we need to calculate out and find out the total surface area of each brick. Okay. So after calculation you can find that this amounts to 450 plus 337.5 plus 150, which will sum up to 937.5 centimeter square. So 937.5 centimeter square is the total surface area of each brick. Okay. Now total area that can be painted is given as 9.375 meter square. Okay. So let us find how many bricks can be painted. So total surface area that can be painted is equal to 9.375 meter square, that is equal to 93750 centimeter square. Area of each brick is equal to 937.5 centimeter square. So to find out the number of bricks required, so number of bricks required is equal to 93750 divided by 937.5, that gives us 100 bricks. Okay. So 100 bricks can be painted out of the container. We have this much area is to be covered, and as each brick has the area of 937.5, 100 bricks can be covered or painted using the paint that is in the container. Fine. Hope you have understood this. Let us discuss question number 5. Okay. It says a cubical box has each edge 10 centimeter and another cuboidal box is 12.5 centimeter long, 10 centimeter wide and 8 centimeter high. Which box has the greater lateral surface area and by how much? Which box has the smaller total surface area and by how much? So let us now discuss the solution. Okay. So students, given the edge of the cubical box, edge of cubical box, okay, that is equal to 10 centimeter. Fine. It is given. So lateral surface area of the cubical box, as we have already discussed, it is 4a square. So a is equal to 10 centimeter and lateral surface area is equal to 4a square, that is equal to 4 into 10 square, 4 into 100 or 400 centimeter square. Okay. So the lateral surface area of the cubical box is 400 centimeter square. Now let us find out the lateral surface area of the cuboidal box. The dimensions of the cuboidal box is given as the cuboidal box. So the dimensions, length is equal to 12.5 centimeter. So L is equal to 12.5 centimeter. Okay. Breadth, that is 10 centimeter and height it is given as 8 centimeter. Okay. So the formula for the lateral surface area of cuboid is 2 into L plus B into H. Okay. So the lateral surface area is equal to 2 into L plus B into H. Fine. So let us now substitute the values to find out the lateral surface area. So 2 into 12.5 plus 10 into 8. So it becomes 2 into 22.5 into 8. Fine. So when we calculate, we get 360 centimeter square. So in this way, we have found out the lateral surface area of cubical box as well as the cuboidal box. Okay. So the first question says which box has the greater lateral surface area and by how much? So clearly it shows that the cubical box has greater lateral surface area, and by how much we can only subtract it to find out that it has 40 centimeter square more lateral surface area than the cuboidal box. Okay. Students, bit 2 asks that which box has smaller total surface area and by how much. So let us find out the total surface area of the cubical box. So here A is 10 centimeter, and for total surface area the formula is 6A square. So 6 into 10 square, that is 6 into 100 or 600 centimeter square. So total surface area of cubical box is equal to 600 centimeter square. Okay. Now what is the formula for total surface of a cuboid? It is 2 into LB plus BH plus LH. So we have the given values, so we just need to substitute the values in the formula. So it becomes 2 into 12.5 into 10 plus 10 into 8 plus 12.5 into 8. Okay. So it becomes 2 into 125 plus 80 plus 100. Okay. So this gives us the value 250 plus 160 plus 200, that is equal to 610 centimeter square. Okay. So the total surface area of the cuboidal box as per the given data is 610 centimeter square. So it is clearly visible that the cuboidal box has the greater total surface area. So what is the difference? So students, difference between the two total surface areas are 610 centimeter square minus 600 centimeter square, that is 10 centimeter square. So as per the question, the total surface area of the cubical box is smaller than the total surface area of the cuboidal box by 10 centimeter square. Hope you understood the solution of the question. Students, let us now solve question number 6. A small indoor greenhouse is made entirely of glass panes, including base, held together with tape. It is 30 centimeter long, 25 centimeter wide and 25 centimeter high. It asks what is the area of the glass and how much of tape is needed for all the 12 edges. Okay. So let us now discuss the solution. As per the given data, the dimensions of greenhouse, okay, that is L, B and H. Okay, the dimensions are length, that is given as 30 centimeter. Breadth is given as 25 centimeter and height is given as 25 centimeter. Fine. So, what is the total surface area of the greenhouse? Total surface area is equal to, see, it is a cuboidal shape. So, the total surface area of a cuboid is 2 into LB plus BH plus LH. So, 2 into 30 into 25 plus 25 into 25 plus 30 into 25. That gives us 2 into 750 plus 625 plus 750. So, it results in 2 into 2125, 2 into 2125, or it gives us 4250 centimeter square. Okay. So, hence the area of the glass, because it is a total surface area, so the area of the glass is 4250 centimeter square. Okay. This is the solution for the first bit. Let us now discuss solution for the second bit. It asks how much of tape is needed for all the 12 edges. Okay. Students, length of the tape needed is equal to 4L plus B plus H. Okay. Length of the tape needed 4 into L plus B plus H. Okay. That is equal to 4 into 30 plus 25 plus 25. That is equal to 4 into 80 or 320 centimeter. Okay. So, 320 centimeter tape is needed for all the 12 edges. Hope you understand the solution for question number 6.
Students, this is the end for today's session. In this session, we have discussed some concepts about surface area and volume and solved some questions. In our next class, we will discuss some more concepts about surface area and volume. Till then, just keep enjoying maths, keep practicing, keep smiling. Thank you.